Hello and welcome to Online Learning with Stephanie. Remember, maths is beautiful. In this video, we're going to look at changing base 5 or 2 into base 10. Now actually, the method that I'm going to show you can actually be used when you're changing any base into a base 10 number. So I'm going to show you examples of either 5 or 2 into base 10, but really it can be used with base 16, base 8, base 4, whenever we're changing another system into base 10. So let's get started. We're going to have a look at the number 4, 3, 1 as a base 5 number. And this is a number that we want to convert into base 10. How do we go about it? The first thing we need to do is work with a place value table. Now, as you get more experienced with this method, you don't have to use a place value table, but initially I find it really helpful to break it down into that and see how it's actually working. So we're going to set up a place value table for base 5 because this is a number that we're working in, okay? Base 5 system. Do you remember what a place value table looks like for base 5? Remember we had a look at these numbers earlier and we're going to set it up based on this. Our place value table always here we have our base 5 to the 0. Then we have 5 to the 1, we have 5 to the 2, 5 to the 3, and so on. We're just going to stick with 5 to the 3 at the moment. Now, what is 5 to the 0? 5 to the 0 is always 1. So I'm going to replace that with a 1. 5 to the 1 is 5. 5 to the 2 is 25, or 5 times 5. So we have 25 there. And 5 to the 3 is 125. Okay, so this is a place value table for a base 5 system. All right, so remember that. You can either memorize this or just work it out as I have done now. So the first thing that you want to do is write your number. Remember, we're looking at 431 into the place value table. The first place value is 1, so we write it there. Second one is 3, we write it there. And the last one is 4, and we write it there. All right, now from here, what we need to do is work out what is the value of each one of these numbers. What are they representing? Okay, this is the ones place value, and we're saying we have one lot of 1. So this is 1 times 1. This is place value of 5, and we're saying we have 3 groups of 5. So we can say 3 times 5. This is a place value of 25, and we have 4 lots of them. So we can say this is 4 times 25. Right, now we need to expand that, solve them, and then add them together. 4 multiplied by 25 is 100. Plus 3 times 5 is 15. Plus 1 times 1 equals 1. So altogether we have 116. And this is base 10. And there's our final answer. 431 base 5 is equal to 116 base 10. Okay, let's do another example. Here we've got the number 324 as a base 5 and we want to turn it into base 10. So again, I've set up my place value table and I've put in each place with its correct value. 5 to the power of 0, 5 to the power of 1, 5 to the power of 2, 5 to the power of 3. So remember, the first thing we have to do is take our number and put it into the table. So starting with the first one, 4, then 2, and then lastly 3. Now remember what these values are, and we can multiply them by how many we have. This is 4 lots of 1, 4 multiplied by 1. This is 2 lots of 5, 2 multiplied by 5. This is 3 lots of 25, so we have 3 multiplied by 25. And we expand them. 3 times 25 is 75, plus 2 times 5 is 10, plus 4 times 1 is 4. And all of this is equal to 89. Base 10. And there's our final answer. 324 base 5 is equal to 89 base 10. Okay, a final example in base 5. We're looking at the number 1233 base 5, and again we want to turn it into base 10. Like before, I have the place value table here, and I'm going to take this number and put it inside. Starting with the last one, we have 3, we have 3, we have 2, and we have 1. All right, now looking at the place values, we've got 3 lots of 1, so we can write that as 3 times 1. We have 3 lots of 5, we can write that as 3 times 5. We have 2 lots of 25, write that as 2 times 25, and we have 1 lot of 125, so we can write 1 times 125. Now we expand them and add them up. This is 125 plus 2 times 25 is 50, plus 3 times 5 is 15, plus 3 times 1 is 3. And when we add this up, it is equal to 193 base 10. Final answer there. So 1233 base 5 is equal to 193 base 10. But what if we want to look at a base 2 system? Well, it works in exactly the same way, and I'm going to show you how now. Okay, just say we have the number 110 in base 2 and we want to turn it into a base 10 number, something we're more familiar with. Now, the first part is we have to draw our place value table. And if we remember from our previous videos, these are the figures that we have for base 2. Like always, the first place value is 2 to the power of 0, then 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. So let's draw that up first. All right, so we have 2 to the power of 0, then we have 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, and 2 to the power of 3 is 8. Okay, so we have our place value table for a base 2 system. Same way, we take the number and we put it in here, starting with the last one, 0, 1, 1. Now this time, the first column represents 1 and we have 0 groups of that. So 0 multiplied by 1. We have one group of 2, so we write that as 1 multiplied by 2. We have one group of 4, so we write that as 1 multiplied by 4, and we have no groups of 8. All right, expand them out. 1 times 4 is 4, plus 1 times 2 is 2, plus 1 times 0 is 0. This is equal to 6 in a base 10 system. 110 base 2 is equal to 6 base 10. Okay, second example, 1010 base 2 as a base 10. And we put our number in, 0, 1, 0, 1. All right, 0 multiplied by 1, no groups of 1, 0 multiplied by 1. We have one group of 2, 1 multiplied by 2. We have 0 groups of 4, 0 multiplied by 4. And we have one group of 8, 1 multiplied by 8. Expand it and add. 1 times 8 is 8, plus 0 times 4 is 0, plus 1 times 2 is 2, plus 0 times 1 is 0. And this is equal to 10 in a base 10 system. So 1010 base 2 can be written as 10 in a base 10 system. Third example, again still in base 2. We're going to take this number and put it in our place value table. We have 1, 1, 1, 1. So this represents one group of 1, 1 multiplied by 1. One group of 2, 1 multiplied by 2. This is one group of 4, 1 multiplied by 4. This is one group of 8, 1 multiplied by 8. We're going to expand them and add them all together. So we have 8 plus 4 plus 2 plus 1 is equal to, that's right, 15 in base 10. And there's our answer. 1111 base 2 is equal to 15 in a base 10. Okay, the last one I want to look at is what if you don't want to use a place value table? It works pretty easy. You just have to remember the numbers in your head. It works exactly the same way, but we try and remember them as we go. If we have a look at this number, 1, 0, 1, 1, 0, base 2. How would we figure this out without using a place value table? All right, what we have to do is we can write them down like this. We start with the backwards. We know that the first place value is 1, so it's 0 times 1. We know that our next place value is 2, so we write 1 multiplied by 2. Our next one is 1, and we know that our next place value is 4, so we write 4. Going over, our next place value is 8, so we have 0 multiplied by 8, and the last one, 2 to the power of 4, is going to be 16, and we have 1 multiplied by 16. So I'm doing the same thing, except I'm not using the place value table. I just have to remember what each place represents in my head. Okay, now I have to expand and add them all together. This is equal to 0, this is equal to 2, this is equal to 4, this is equal to 0, and this is equal to 16. So altogether it equals 22 in a base 10 number system. So whether you're using the place value table or whether you're remembering in your head what each value place is worth, it works the same way. Whether you're working in a base 2, a base 5, or even a base 16 system and you're converting to base 10, this is a method for it. Write down each number in its correct value, multiply it out, add them together, and you will have your number in a base 10 system.